Log2timeline is an extremely powerful tool for its use in forensics and log analysis. It is a part of the Plaso suite of tools, which contains Log2timeline, pinfo, psort, psteal, and image export commands. They all have their own individual uses and work hand in hand to create a super timeline. A super timeline is the combination and an assortment of all of the log files and events in a system. The powerful attribute of these tools is not only the ability to combine all events from log files into one comprehensive document, but to filter based on the information you want to look at. Log2timeline.py is the primary tool in this suite that you'll be using. It's the command that starts the entire process of creating a super timeline. It includes many different arguments that can be added to change the output. You can filter by artifacts, filter based on the original file path, parse out specific events through the use of pre-made commands, and much, much more. The command starts with the input of either a file, directory, media image, or full device to create a Plaso file that holds a super timeline. This Plaso file is in a SQL-like database format, and on its own isn't all that useful and not very easy to read. So then you need to use the next command, which is psort. Psort takes that Plaso file created by Log2timeline and allows you to filter, sort, and run analysis on the file contents. This command gives you another layer of filtering and allows you to use analysis plugins and slice out specific times. For this command, you'll be able to specify the intended output file format, and you have the option to change the output fields, offset the time, and even change the language. Depending on the file format you use, you'll be able to view the file with different kinds of spreadsheet viewers. And from that point, when you're viewing it, you have even more ways of filtering, sorting, and organizing the data. psteal.py is a combination of both of those tools. Rather than having an intermediary file, that Plaso file created by Log2timeline, it just full creates that output on its own. This tool will be faster than using the other two commands, but it's much less powerful. It has limitations on the kind of arguments that you can use for it. And on top of that, if you create the super timeline through Log2timeline and then you want to somehow sort it differently or slice out a different section, you're not going to be able to do that using psteal. You'd have to start the command from the start again. So it's not something that you're going to use very often, other than maybe a quick analysis of a singular or just a couple files. But for a full disk image, you're going to want to go through the whole process. All the commands that I just talked about are also extremely resource intensive. The initial sorting of all of machine's events and log files can take anywhere from a couple minutes to a couple days, depending on how much resources you have on your computer and the size of the initial input. So due to this, the creators made arguments that allow you to specify the processing power. You can limit how much CPU you use, how much memory is available, how many different workers it has, etc. pinfo is also another command that just gives you information about the file created. So if you run the Log2timeline tool, it might take a day. So you might want to use pinfo on it afterwards just to check if there were any errors, or if they're just to double check the arguments that you gave in the first place. It shows you things like the initial command used, how long the time was taken, different parsers and errors, many other things. The last tool in this suite is image export, which on its own doesn't really need to be used with the rest of the tools. It's just a different version of creating a file from storage media or device. It's just another disk image that you can create. I want to start off by showing some of the help menus for these commands. So you're just going to type out the initial command name. So it would be log2timeline.py. .py comes after all of the commands in this suite. That just signifies to open it with Python. And then you're going to type -h, the argument -h, which brings up the help menu. It's the same on all of these commands. And if you just put concatenate less, it makes it a little more readable since it is a long output. So I highly encourage you looking through this if you do intend on using the tool. It gives you all kinds of information about the different artifact filters that there are, the different orders for the commands, the different hashes that you can use, how to make Yara files for artifacts, buffering size, how to change the names of log files, and the complete order in which to use everything. So then there's also psort.py. This one also, you can get a full-on list of all the different analysis arguments and change a bunch of different processing things. Change different filters, such as taking out based on date and time. You can change the default time, and this menu will tell you how to signify all of that. It does get these commands get a little bit long, so you're going to want to take a look at this menu very often. If you see the output right here, the -o format, you can actually use -o list to get a list of all the different output formats, and I'll show you that later. And then the other commands aren't as difficult to use, and I won't cover those yet. I wanted to start off by just giving a very basic example of how this is used. So you can see on the right here, I just have a quick notepad brought up with two commands that I'll use to create a viewable file. So I'm going to start with log2timeline.py, then list my storage file, which is going to be my output, and I list the home directory there, and I just create a directory called output, and then create the file auth_log.plaso. That file hasn't already been created. This command creates that file, so you don't need to worry about touching or anything to create that initial file. Then I list the input, which I'm just taking a singular file out of the already existing log files on this machine. So /var/log, you see a bunch of different files in there. I'm just taking the authentication log out of that. So let me type that out. Log2timeline.py --storage file /home /alex output auth log.plaso. You don't need to specify the file extension name. I'm just doing that for readability's sake. Then you list the input. So /var/log/auth.log. You can use tab to complete these commands also. And I want to point out one unique thing about these commands is that it lists the output then the input, not input output like many other Linux commands do. So just remember when you're running this command, I've gotten it mixed up many times. Then you just go enter. This is the file where it runs everything, and you can get a lot of information from this. I'll go over it later when I have a longer command that goes on. This one's fairly quick, only took about 8 seconds. So now I'm going to run the psort command. So psort.py, I have to start by listing the file type. Right now I'm just going to list dynamic, which just makes it morphable to anything that I want to read it to. Then I have to list the output file, so -w, which would be write. I'm going to create auth log readable, and I should actually list the entire directory for that. So I'm just creating it in my output directory, auth log readable, and then I'm listing where it comes from. So it would be home, Alex, output. You can double click tab to see what's in there. I already have the auth log Plaso. I can tab to complete that and just run that command. Now you can see it's running, completed almost instantly, and If I go back to my output file, ls, you can see I have authlog.plaso and authlog readable. Now that we've used psort and log2timeline to create a readable file, I can see them right here, authlog.plaso and authlog readable. I can try and view those. So let's just use the tail command to get a little bit. Authlog.plaso. That was the one created by Log2timeline, which is going to be the SQLite database. When I use that, it's not really readable. That's because it's just not in a format that we can read. So when I use tail on authlog readable, you can see this gives me something more viewable and more easy to understand. Now, you don't have to do this through the terminal. You can actually open this file in a spreadsheet. So if I go to my directory right here, I can open with an application. Let's use LibreOffice Calc. This will just create a spreadsheet with all that information. You can use different commands. You can even go to Excel if you want, but it just gives you a way to organize, filter, and view the data. So now let's get a little more in depth with this tool. Rather than using it on a singular file, I'm going to use it on an entire small directory that has a couple different files in there. Once again, I'm going to use the same directory for the output. So this time I'm just naming the file verilog installer.plaso, and I'm drawing from just about the same location, the verilog installer directory, which has a couple of different log files. I'm not filtering anything out, I'm not parsing anything yet. Let's run the command, and it will just take a couple seconds. It's not a large directory, there aren't too many sources, so it'll just take a couple seconds here. And there we go. We see that it generated a couple of errors while it was running too, and it tells us that we can use pinfo to inspect those. So if I go ahead and use pinfo.py, and then I can type out the location, so it'd be verilog installer.plaso. I'm already in that directory, so I'll just use my current working directory and just type the name of the file directly. Go ahead and press enter, and this is pinfo. So it gives us a lot of information on what the file is. So it gives us the name, sessions, how many event sources there were. So there were 10 directories in that folder that I was looking at. It tells you the events generated per parser. So it only had to use filestat, and it got 13 events out of filestat. And it also tells you which had warnings. Now this isn't too much information. It doesn't tell us what the errors are. So I'm going to go back, and instead of just having the basic command, I'm going to add the -v argument there, which is the verbose argument. Just like many other Linux commands where you type -v, it gives you more information. So now I have a lot more to work with. If I scroll all the way up, this time it gives me the start and the completion time. So it shows us that it took only about 10 seconds. It gives me the full command line argument that I used. And you might notice it was a little different than what I typed out. It has -user bin log2timeline.py. That's where this command is located. And then rather than using the current working directory like I used, shorthand, it used the full working directory. So -home-alex-output / verilog installer.plaso. Then it shows us all of the enabled parsers and plugins. I didn't use any filters, so it says it shows NA, and by default, all parsers and plugins are used. So this is the entire list of them. And then it shows all of the sources. So you notice how it said 10 earlier. This starts at 0, goes to 9, and it shows all of the files and directories in the installer location. If I scroll all the way down, I start to see these extraction warnings. Unable to process path specifications with error, unable to open file object with error, permission denied. So that permission denied just becomes, from Linux, it's readable only by an admin user. So I could have gotten past that if I would have done sudo in front of the command. Although with these commands, you don't necessarily want to use sudo because you won't be running into this specific error. So most of the time, you'll be using this tool to analyze other machines' images, not files on your own computer, so they won't be limited for permissions. So you usually don't need to use sudo. This is just an example of how to look at the errors that are generated. So now that we've looked at that, let's go ahead and psort the command so we can get something usable out of it. So psort.py, and I'm not going to go ahead and put any arguments other than -o, which is the formatting. I'm going to make it dynamic, which just allows it to change to what I need it to. And I'm going to write it to this working directory right now. So let's name it var log installer for the file that we need. And I'm not going to give it any extension, so it can go ahead and change to what I need it to. And then I'm going to list the input file, which is in that same directory, var/log installer.plaso. And I'm going to run that command. It should only take a second, and it's complete. So now I can take a look at what was created out of that. I'm going to use the less command, var/log installer, and those are all the events that came out of it. Again, you can read this out of some kind of spreadsheet viewer, and you can filter and sort it through there, but this is just a brief demonstration of how to view the file. So now I wanted to touch a little bit on parsers. So you can start with the log2timeline command, log2timeline.py -- parsers. Then you can use list to create an entire list. It's going to be a little long, so I'm going to again use the less command to start with it. So this will show the entire list of the parsers and a slight description of what they're used for. You can see there's the Chrome cache, there's the Firefox cache, there's Android stuff, there's different Windows, firewalls, Microsoft logs. You can look at file history, Amazon Web Service CloudTrail logs, all different kinds of parsers and plugins. Then at the bottom here, it shows some presets. So if we want to take a look at the Linux preset, which I'm going to use, I can see that it takes out APT history, Bencode, popularity contest, SQLite / Skype, syslog files. Many different parsers are included in this. And if I take a look at the Windows 7 parser presets, if I look at the slow one, this one has included in it Win7, which will include all of these parsers in Win7, which includes WinGen, which includes all of these. So they're somewhat cascading even with all of the different parsers that are included in them. So knowing the parsers, now I can use a log2timeline command with some parsers. So I'm going to take the whole var log directory and just parse out the Linux files in that. And then I'm going to again put that in the same output directory. I'm using the sudo command with this one because we ran into that error earlier where it couldn't open certain files. So I'm just using that to bypass the error. So now I want to take a little look at this screen here, which is what you're going to see while a command is running. And this can run for a very long time. It can take just a minute or it can take days. It all depends on the amount of resources that the machine has and the size of the files that it's looking at, or the size of the image, or whatever the source is. So at the top here, it shows us the path that I'm looking at and what it is. It's a directory, and how long it's been going. Under that, we see the tasks queued, how many are being processed at one time, merging, abandoned, and total. So certain tasks will be abandoned if they are stuck for a certain period of time. This won't happen on this directory, but it does show you the growing total there. Then there's also the identifiers. The workers are the different CPUs or whatever is working to go through these files and check for the events and extract these events. I didn't give many resources to this machine, so it only has 2 and it's running on limited memory, so this will take a little while. But we're seeing a growing total of all the events through the main and the workers, and over time it will finish. So the command took about 10 minutes to finish, and if you wanted to, we can take a look at the pinfo page, pinfo.py, verbose mode, and then list out that file. So the Linux parse.plaso. It also had some errors with the syslog files, but it just went ahead and skipped over those when it couldn't view them. This isn't that big of a deal, and it's not worth going back and trying to fix access to that. But if we scroll to the top here, so now I'm going to go ahead and p-sort that same file that I was working on earlier. This time I'm again going to slice out a specific piece of information. So I'm going to use the slice command. This allows you to take out certain periods of time, and if not specified, it's just going to go 5 minutes after the time that was listed. I'm going to use the dynamic format and write to log filtered time CSV. Then I'm going to list my input file, which is Linux parse Plaso, and go ahead and enter that. Doesn't take long. The p-sort is a lot quicker than the Log2timeline because rather than looking through all the files, it's just looking through what was already generated. So right here you can see all the files that were taken out. It took from 5 minutes before and 5 minutes after the time listed. So you can see 3:25 to about 3:35 shown at the bottom here. And it shows me all the different files that were taken out. This is the column for which parser was used. And you can get all your information on that. As my final example, I'm going to take the entire log timeline of a disk image for a Kali Linux machine that I've put some use into. So I'm going to run the Log2timeline command, log2timeline.py, list my storage file, I'm going to call it kali.plaso, and then list my input file. I'm not going to bother with filtering or parsing this at all. I'm just going to take all of the files out of this. From the home, Alex, input, linux.dd. So you can see here that I ran the tool and it took about 5.5 hours to complete. This is a very intensive tool to use, and you can see how if you were to run this on a disk image of an entire server and all the log files in there, if you don't have many resources on the machine running the command, this could take days to run, especially when you're just grabbing anything. I didn't parse by anything specific, so it just grabbed every single event and log that it could. So let's go ahead and quit that menu. Now we need to p-sort the database created from that. So I'm going to go ahead and use p-sort. Again, use dynamic. Write it to kali.csv. And then list the input file, which would be linux.plaso. And run that command. Again, this will take some time. It's not going to take as long as the Log2timeline command, but it still will take a while. So here's the CSV file, or XLSX file, of what I just parsed from the entire machine files. You can see there are hundreds of thousands of event logs. And to try and find anything specific out of this would be crazy. This is why you really want to filter and parse out that information early on before you get to this phase, so you're not just scrolling through, hopefully trying to find something. You can slice out by time, filter by what the data includes, parse out by what is already deemed as appropriate for this command, and hopefully not end up with hundreds of thousands of different events. You might want to choose carefully what file you use to open this too, because I'm using only Office right now. It's running very slowly and took a long time just to open this up, and even worse is LibreOffice Calculator. This is a little more lightweight, but I have had it crash on me a couple times just trying to scroll through it too fast. There are much better ways of opening this, although I'm not going to get into that. There are different ways you can filter Excel to color code different types of information, and even change the way that the information comes out through your psort command and add different fields in there. To give a slight summary of these tools, it's very important to remember that Log2timeline is the first tool to use in this that creates the super timeline of all the event files and logs. Then you sort this with the psort command, which allows you to filter, sort by time, slice out times, filter by source file, and run automatic analysis on the contents of the file. From there, you can then view and look at this logs for all of your forensics needs. You can try to look at what specific time someone opened an executable, or what executables were run. If there was something that was suspicious, say you find an evil.exe that you find, and then you can look more into that using these filters to try and get all the information that you need out of this seeming ocean of log files and events that might be overwhelming to look at without any kind of filters.